Hello, everyone. Thank you all for joining the webinar. I apologize for being 1 minute late, having a little bit of webcam issues, but nothing like a good webinar for having that happen. But we are going to give it just 1 more minute before we get started, just for 2 after the hour, just in case we get a couple extra people on. And then we'll go through some introductions. We got some good poll questions for you. Also, we'll take the time now that to mention that there's a chat box on GoToWebinar. So if you do have any questions, we will be moderating the chat, and we will have about 10 minutes at the end of chat, or at the end of this webinar, to go through some Q&A. So feel free to get those in. We'll also follow up after the webinar with any questions that we missed. All right. Well, let's go ahead and get started. Thanks again for everyone that's joining. My name is Kyle Miller. I'm on the solutions engineering team here at DJI. I've been here for about a year, got into the industry, the drone industry, actually from an agriculture perspective, but through working at Drone Deploy and a couple other hardware providers, really gotten the surveying background and also done quite a bit of cell tower inspections. So with that, I'm really excited that we're able to also partner up with Pointivo and talk a little bit more about their solution. So Colin and Jacob, should we go through and do some introductions?
Sure thing. Thanks, Kyle. My name is Jacob Garland. I'm Chief Technology Officer at Pointivo. Been with the company for about 5 years. I'll tell you a little bit more about Pointivo here in just a little bit, but before then I'll pass it over to my colleague, Colin.
Yeah, and I am Colin Blake. I'm Director of Solutions Engineering here at Pointivo. I've been here about 4.5 years, longtime drone enthusiast. Built my first drones over a decade ago, and I've been doing that as a job now. So good to be here. Thank you.
Perfect. Well, with that, let's go ahead and kick off the first poll questions. Go ahead and hit launch. So you should see a poll pop up now. Overall, the main question is have you used drone data before? We're just trying to get a broad understanding of who on the call is more experienced, who is just trying to get a better understanding of how drones can be utilized for cell towers. So looks like we're about 2/3 yes, 1/3 no. So decent amount of newcomers, which is nice. Give it another 5 seconds here. All right. Thank you for all that voted. We'll close that. You guys should still be able to see my screen. We go ahead and walk through. So on the agenda, the first thing that we're going to be doing is talking about the hardware to go out and capture this data. And then after that, we're going to be talking about what we do with the data processing, and where Pointivo can leverage its expertise in the cell tower inspection game. So to capture the data, I really want to focus on the drone that we released last year. We've got the Mavic 3 Enterprise. I do have the Matrice 300 back. It's got the H20T on it, but we are seeing a lot of customers utilizing the M300 and the P1. But overall, and that is a really great method of capture with really intensely clear imagery, but for the price point of the Mavic 3 Enterprise and what it can do, and with the new point of interest orbit tool, we're seeing a massive uptick of having this drone being the new industry standard. So a quick overview of the Mavic 3 Enterprise series. We released actually 3 different versions, but we're going to focus just on 2 of them today, the Mavic 3 Enterprise and the Mavic 3 Thermal. So overall, it's a nice upgrade from the Phantom series. The Phantoms flying for Colin, Jake, how long? Like maybe 30 minutes tops for a cell tower. And we're capturing photos every 2.5 seconds on pre-programmed missions. So Dealing with that, we wanted to see some significant upgrades when we get to the next generation of platform. So Mavic 3 Enterprise, we now boast 45-minute flight time. It does go down if you have the RTK module on there, down to 42 minutes. It also has a larger sensor. So we're working with still a 20 megapixel sensor, but now it's a 4/3 inch. So if you're doing cell towers maybe a little bit later in the day and you get the conditions where you're getting a lot of bright sun on one rad and the other rad is shaded quite a bit, having a larger sensor is going to help out with that dynamic range to help build a much cleaner model where you don't see that massive sun shade on the rad. And then also, if you are going with the Mavic 3 Thermal, that has a smaller visual sensor, but if you do need to do some thermal inspections, you can go that route. We are going to mostly be talking about 3D reconstruction though, and that's where I'm going to be focusing on the Mavic 3 Enterprise. So with that, we kind of talked a little bit about that sensor already. The big thing to highlight here is the efficiency increases. So fly longer. The point of interest tool, we did have that on ground station, but now we're implementing that into Pilot 2. So we have some of the same functionality. We keep integrating new versions with new firmware to bring more functionality there. But now we bring the minimum photo interval to 0.7 seconds. So I don't know if you guys have seen a cell tower captured at 0.7 seconds with the M3E, but that thing can capture a monopole real fast. And then also smart low light photo. We've got a larger sensor size, so that's going to be able to help out there. And then the big thing there at the very end, RTK. This is something that's completely detachable. It's through the payload SDK. And when you look at the price point, now with this $700 RTK module, we're now comparing it from the Mavic 2 Pro, Phantom 4 Pro line to the Phantom 4 RTK line. And overall, the price point for being under $4,000 for a bundle and then $700 for the RTK module, we're already under the price of the Phantom, and it's better than the Phantom. So it's been a nice increase to see. We also have a telephoto lens. So I know we're focused a lot on 3D reconstruction here, that we're mainly focusing on triggering that big sensor, but the nice thing about using the Mavic 3 Enterprise compared to the generational Phantom was that Phantom was a single sensor and it was meant to do one thing and it did it pretty well. Now we can pinch in and be able to zoom pretty tight in on objects. So having that, basically it's another 12 megapixel sensor that is at a really deep focal length. So as you zoom from 1 time to 7 times zoom, that's basically digital zoom on the main large sensor. And then once you hit 7 times zoom, you have a brand new 12 megapixel sensor that you can go ahead and punch in all the way to 56 time digital zoom. So a nice improvement that it becomes a dual purpose drone, not just a reconstruction drone, but also a light inspection drone. Improved surveying accuracy. So I keep bringing up a couple features, a couple highlights, but if there's on the spec sheet, if I could just grab a highlighter and just hit a couple of the important parts, it's going to be flight time, capture speed, sensor size, and you're going to see a lot of that here. So don't need to necessarily reiterate, but when you do go out and make those general mapping missions, you can be flying, you know, even 100, 150 feet off the ground and still be capturing crisp imagery with that mechanical shutter at 30+ miles an hour. So yeah, and then also a little bit faster charging. If you do need to just stay up in the air all the time, you're gonna get the drone to charge from, it takes 70 minutes to fully charge a battery, but we're seeing 20 to 90% on these Mavic 3 batteries in like 35 minutes. And so having that battery charging hub and a couple sets of batteries, you should be ready to roll. I'll ask Jacob and Colin, what have you guys heard about some of the difficulties of flying cell towers, especially flying cell towers up close? Would you say transmission and RF is going to be one of those main factors?
Yeah, absolutely. It can be, you know, seemingly random. I'd say 98% 8% of the time it goes off without any real issues. Sometimes we'll see GPS issues. Sometimes there's transmission issues. I will say I've not experienced any to date with the Mavic 3 Enterprise. So seems pretty rock solid in that regard.
That's great to hear. Yeah, and with the OcuSync 3 Enterprise transmission system, that's a nice upgrade from those that were doing cell tower inspections with the Phantom series. So we've got more range, or that essentially equivalates to, if you've got more interference, you're going to still be able to punch through and be able to have some fairly good video feedback. And if you're talking RF, cell tower inspection is going to be one of those hardest places to fly. You may not get a whole lot of compass issues, but you always want to maintain control of the drone. You always want to maintain GPS lock. And when you're talking about something that's more economical on the enterprise side, from what I've heard, this drone, comparative to some of the others on the market, can just really keep that rock solid transmission system. If you need something more though, we've got dual and triple redundancy sensors when you come to the M300. And the cell tower capture process. So this is something I really wanted to focus on this webinar, is the new point of interest tool. So the process of setting up a cell tower capture with this is 15 seconds. Like once you've done maybe 2 or 3 of them, it is very simple. If it's a monopole, you fly to the very top of the tower, you drop a pin. I'm not sure if you can see my mouse, and I'll go ahead and hit the play button. Hopefully it loads in here. Oh, my video is not loading. Oh no. Oh well. Well, you hit the icon, the little diamond icon, and I think if I click on the next option here, when I click on the diamond icon, it pops up my new orbit tool. I'm then going to manually fly the drone off of the tower and focus on the first rad. And then at that point, I can come in here and change my camera settings. Remember, we've got a 0.7 second trigger speed here. So I'm going to set my timed or time lapse all the way up to 0.7 seconds. So I've got that locked in. And then from there, once I've got centered the rad, I can go ahead and click on the orbit and the point of interest is enabled. I can then trigger on my time lapse. And now all I have to do is hold my right stick of the controller. And you can see there's a C1 that says speed set. I'll just tap on that and it's going to be locking in the speed. At that point, I have a drone that's capturing imagery and just freely or spinning around a cell tower. So I've done everything, and I know that was a lot of steps. Basically fly over it, tap one button, back off of it and focus on the rad, tap the orbit button. Take the right stick, go to a very consistent speed, lock in the speed, and then tap on the time lapse button, and I'm ready to go. From there, all I have to do is just slowly, once it goes all the way around, I'm just going to drop the altitude a little bit and then just slowly make my way down the tower. I know it's not fully automated, but when we're talking about a scalable solution, and if you can get 95% of the way there, and it only takes 15 to 20 seconds of setup time, then you're talking about a whole lot of towers that you're able to capture. Does it actually play? Shoot. Well, from there, I think we were able to explain it fairly well of the process, but then you have a freely spinning drone where you can just slowly move down the tower. You can also back up if you need to, if the rads stick out, or if you have if it's a very large tower that has multiple platforms, you can back up and recenter that orbit fairly easily. At that point, you can go ahead and pull the SD card out of the drone and then put it into whichever platform stitching provider of choice. We do have DJI Terra that's built in, not built in, but as a photogrammetry engine, but we're gonna be mostly talking about Pointivo. I do have one last shout out. That's going to be with DJI having the mobile SDK and the payload SDK. So first off, mobile SDK, that's going to allow third-party clients or partners of ours that they're going to be able to control the drone or write an app that installs onto the controller that controls the drone. And we may not get everything right within the Pilot 2 app. We fully understand that. There are a lot of use cases for drones across the enterprise perspective. But when we look at some of the other clients that are in the cell tower community, do want to shout out one partner, DroneLink. The one reason why I wanted to shout them out is we do have a somewhat significant percent of guide towers, especially here in the Midwest. I'm in Eastern Iowa. And so if you do need to make a more complex flight mission and you want to test out something other than the Pilot 2 app, because the point of interest orbit, it's going to freely be spinning, and don't trust the obstacle avoidance around guide wires. I don't care what drone you have and how good of radar it has, just don't trust it. And if you can make a little bit more complex flight plan, something like that, DroneLink is one of those partners that I wanted to shout out that's able to help. But now that you've captured the data, the really crisp, clean, accurate data with RTK, how do we then take the data and put it into Pointivo? And at this time, I'm going to transfer it over to Jacob to talk a little bit more about Pointivo in general, and then Colin's going to be walking through the actual platform.
Yeah, thank you, Kyle. And yeah, we have no personal experience whatsoever in clipping guide tower wires with drones. Colin's smiling.
Let me, I do have a poll question I want to kick off while we maybe banter a little bit, and then we'll jump right in, Jacob. But
Sure thing.
With this poll question, do you currently use any drone software for processing data after you've captured with the Mavic 3 Enterprise? So very, very fitting question of what do you do with the data afterwards? And we're going to be showing you exactly what you can be doing with Pointivo. So pretty excited about that. Colin, you've maybe clipped a tower or guide wire or two in your day, or are you perfect pilot?
I have indeed. It's a not fun experience, but I will say, if you're flying near towers and guide towers especially, it's definitely nice to have DJI care.
Yes, it sure is. And it's not saying that we're going out and doing this every day. It's just with these environments, it's probably one of the most difficult environments to be flying around when you're talking about the entire enterprise space, just a lot of guide wires. All right, let's go ahead and close. Looks like about 2/3 of people are using drone software already. So we'll close that, and let me go ahead and change presenter over to Colin.
Excellent. So while Colin's firing that up, I'll just want to say thank you, Kyle. Thank you, DJI crew, for joining with us in this webinar today. We're really excited to be here to share a little bit about you know, how we're revolutionizing the telecom industry with AI-driven analytics and the power of the Pointivo software platform. So while just to give you a little bit of background about Pointivo. So Pointivo was founded in 2014 out of a research project through Georgia Tech Incubator. Our chief science officer, Habib, did his doctoral thesis on structure from motion, from imagery, and we have a long history of creating digital twins really before, you know, the term digital twin became a thing. We hold 19 patents across different aspects of digital twins. We've been deeply rooted in the wireless telecom industry for a number of years. We work with customers in all sizes and stages, from Fortune 500 enterprises to mom and pop tower owners to structural engineering firms, all of them using our platform to process thousands of towers per month. And so when you were talking earlier about the speed and being on site, like when you're operating at that scale, every minute counts, every moment on site matters. Anyway, we love interacting with directly with our customers and deeply understanding the problems and challenges of the industries we serve, like wireless telecom. And we think of ourselves as kind of an innovative crew. We're scrappy. It's just in our DNA. We like getting our hands dirty, and we believe the best way to solve problems is to first deeply understand them. And so imagine yourself one hot August day, Colin and I are doing customer discovery on site in the middle of nowhere, Indiana. We're joining up with this tower, this climbing crew and field technicians who are doing inspection work on a guide tower. And we're shadowing them to get a firsthand look at their processes, their daily work, what they're doing in the field. And we were also planning to do a flight on site that day to basically do an ROI case study on drone captured data versus tower climbs. So Colin and I show up, and when we show up, the gate to the compound is open, and we get out of the truck and we're immediately greeted by this guy running out from behind the compound shelter, screaming something about hornets and, you know, whatever, just a big commotion, right? And he's like running towards us, and we're fleeing, you know, like whatever he's encountered, we don't want to have any part of it. So we all retreat from the area. And he mentions that when he got there, the gate was already open. And even more strangely, the door to the shelter was open and the keys were in the door. And so we're, you know, scratching our heads about that. And about that time, another tower crew, like completely unplanned, a totally different tower crew, pulls in behind us. And this guy jumps out and he's like, "Hey, you guys might want to watch out. There's like some really bad hornets back there in the compound." And so the guy that met us, you know, his face is like swelling from the hornets. And he's like, "Yeah, that's totally new information. I appreciate that." And so but what had turned out happening was this other crew had shown up before all of us, encountered the hornets, fled the scene, didn't even get the keys out of the door, and then went to Home Depot to buy wasp spray. So anyway, it was a whole scene, right, in the middle of nowhere, Indiana. So we're all like 3 different teams all here in rural Indiana, all doing work on this tower. We've all flown in from town or driven pretty great distance to be at this location. And multiple teams basically getting information about this asset for different parties who are all ultimately going to use this information in a variety of different ways. And I think it was in that moment that I really realized just how much time is spent just trying to get basic information about the condition of a physical asset like a cell tower. Hours literally are spent traveling, climbing, taking pictures, measuring stuff, organizing that, getting back to the hotel and uploading data. Just the list goes on. And you multiply that times the thousands of assets that there are out there, compounded by different stakeholders needing different bits of information. And even in the best case, you're left with a mediocre amount of data locked away in PDFs and construction drawings and shared drives on the network. And it's just, there's a better way, clearly. So, you know, many of us on this call already get, we don't have to be sold. Like, we know the value of a digital twin. We understand the value of drone data and drone capture. But there may be others on this call that may not be familiar with some of the key problems we face in the telecom industry specifically. And so I wanted to take, I could talk for hours on this, but like I wanted to take at least a little bit of time to talk about some of those unique problems from you know, the years that we've spent in the wireless telecom industry. So number one, we already talked about a lack of visibility, right? Like in a perfect world, if you owned a bunch of assets, a bunch of towers, if they were all in the front yard of your office complex, that would be great. You could just go outside and look up there and see what's going on. But the reality is they don't. They're spread out over vast distances, and without being physically present, you really don't know what's going on that site. There could be problems with antennas, mount systems, trees falling on, you know, perimeter fences, You could have customers installing equipment outside of leased areas. It's not just necessarily about problems on the site. It could be lost opportunity, lost revenue opportunities even. Things like being able to determine if there's enough space in the compound to fit a new tenant, right? That's even in the best case, if you have really good records, you still might not have enough information to say for sure. So data is in different siloed locations, it's in disparate sources, and people are constantly trying to pull this information together to make sense of it. You've got, just like we were talking earlier, manual processes, people getting in trucks and literally driving out to sites and taking pictures and writing on clipboards and coming back to the office and copying that into different systems. And then uniquely, or somewhat uniquely to the wireless telecom industry, is there's a lot of consolidation happening in the market, meaning there's a lot of larger tower owners purchasing the tower portfolios of smaller tower owners, and records become really important in those transactions. There's due diligence that happens, inspections have to be done, and when there's not good data, that process gets really drawn out. And so really with all of that consolidation in the market and those processes coming to a halt, this is a big problem. So we think there's a better way. We know that there's a better way. From a digital twin perspective, I don't have to sell this group on the value of generating mapping data or generating photorealistic 3D models, right? We perceive the world around us in 3D. Not in spreadsheets, and so it's a natural way to get better information. You go fly a drone, you create a pretty photorealistic model, and you can do a lot with this model, right? You can do inspections, you can take some simple measurements, and many in the industry refer to this as a digital twin, and it is of sorts. But at Pointivo, we kind of think of that as like an industry buzzword that's kind of been conflated. We think of it as much more than just a pretty model. We think that it goes beyond that, and really it sees its true value when it's integrated with business data to solve real world business problems. So it's unifying to the organization. It becomes the centerpiece for conversations. It becomes a place to convey business information, new insights, the ability to accelerate decision making. There's just so many different benefits. And it's even embedded. We see a digital twin being something that's embedded into internal workflows and is helping drive efficiency in the organization. We see that as a leap forward, from traditional like asset management systems. And like, there are a lot of people in the industry that are still managing their assets through literally spreadsheets, just spreadsheets of rows that represent those towers. And what we think of as a digital twin is we want to be the conduit to the real world. It's kind of like if you were looking, I say this all the time, it's like the row in the spreadsheet, it's like double click on that row and you're now teleported to that location, and you're seeing this asset in its life cycle over time and really able to understand that asset. And so in our view of digital twin, it's really about a number of different areas. Sure, it's about physical asset visibility and efficiency. Those are key tenets of our solution, but really automated data analytics, the power of AI and automation to replace what have traditionally been very manual processes. Like I mentioned before, we hold 19 different patents in the application of AI, computer vision, machine learning, 3D reconstruction, virtual navigation of digital twins. We apply this technology to outputs that we use to deliver benefits directly to our customers in the telecom space, like mount mapping, tower mapping, inspections like the TIA 222, lease verification and compliance, feasibility studies, post-construction inspections. I mean, the list goes on. And all of this data really is helping feed downstream systems within the enterprise, like maybe other systems of record that already exist, structural analysis software, engineering tools, all sorts of things like that. And then, of course, all of this, helps accelerate not only the efficiency of the organization, but accelerate things like M&A for tower portfolios. So lastly, just one quick thing before we jump in and show you guys a demo of what we're doing at Pointivo. I did want to talk briefly about the various stages of adoption that we see. And this is really not necessarily specific to telecom, although for tower analytics, this is the sort of the natural progression that we see. All of those that we've talked to over the years, and we work with companies at all different stages of adoption, in all different sizes. They really fall into one of these four key stages: R&D, early stage, scaling, and enterprise. In sort of the R&D mode, we typically find one or two individuals that are kind of like the scouts for the organization. They're going out and they're doing trade shows, they're doing some investigation, they're talking to people about what's possible, really just exploring like the technical feasibility, and essentially they're making a case internally about what is possible. In the early stage of adoption, really it's about, you typically find like a small innovation team within the organization. They're doing some experimentation, maybe they're doing like proof of concepts. They're typically around like a specific use case. They're exploring what's possible, how that might impact their business, and they're representing a bigger team of stakeholders in the organization. Once there's sort of a flipping point right there that now enters into scaling and enterprise, and this is really where we see in the scaling stage, the value has been proven. Internal adoption is really in specific key areas, but they're looking at this point. They've proven the value. It's about how do we get more of it, and how do I get more, find new ways to use this this new intelligence. And this is really where we start to see digitization strategy at the company level starting to scale. And then the tension has been shifted to how do we scale this thing. And then finally, in the enterprise case, we see organization-wide recognition of the value. It's a part of a digitization strategy. We see multiple business units within the organization, benefiting from analytics, and that's really where we start to see scalability and repeatability of capture and of analytics is like paramount. So finally, one more thing around the drone program strategies that we see in play across these different adoption stages. In the R&D and early stage, we see a lot of outsourced drone strategies. They're working with DSPs to provide pilots and equipment and insurance and that sort of thing. And it's because they haven't yet established a solid case that can actually extend out into the scaling stages, as companies are still, they just want a turnkey solution. They may not necessarily need to build out a flight team. Hybrid is where we start to see maybe an organization is now taking drone hardware and equipping their existing workforce with that drone. So it's field techs, SMEs, that know what they're doing on site from a wireless telecom perspective, like RF engineers and things like that, equipping them with drone hardware and letting them use that as like another tool in the toolbox. And then finally, we see a lot of companies at the enterprise level anyway, moving towards an internal team where they're actually creating a flight operations team. They're doing training internally and that sort of thing. So we're pretty agnostic, Pointivo is, from a data capture standpoint, but we also recognize that the analytics are going to be as good as the data coming in, And in telecom, data capture is obviously a very important component of the overall solution. And that's why, given the nature of cell towers and what we're doing every day, the drones, and particularly DJI drones, really help and make for a perfect fit there. So without further ado, let's take a look at what we're doing here at Pointivo, and I'm going to turn it over to my colleague, Colin.
Thank you. Yeah, so we are going to jump into the demo here. I'm going to start out just kind of giving a brief overview of how we sort of organize the information. So when we onboard a new organization or a new customer at Pointivo, we set up a dedicated portal for that particular user or for that organization. That organization is in charge of who has access to the data, et cetera, and the company who captures the data or for whom we are capturing data owns all of that, all of the data. Our dashboard has basic information, including tower names, tower IDs, owner, type of structure, and we present all of that in a map view here as well. From here, you can either launch into a specific tower by choosing it from the map or from the list, and once you do that, you get brought into our tool here. So I've got a tower here that we've done various different types of processing on, but before we get into the specifics of that, one thing I did want to touch on a little bit, and we talked about different ways of capturing during the presentation on the DJI side. We have spent a lot of time optimizing flight paths for tower capture, and we provide our users or our customers an automated flight solution, again, that we've customized to really minimize the amount of time on site while ensuring that we produce high quality models. And so you can see here it consists of columns and orbits. The columns ensure that we get the entire structure. The orbits focus in on the areas of most interest, namely the rad centers and the compound, so that we get a full picture of the entire site, but lots of detail in the areas where it's most important. This allows us, on a tower of this size, we can capture this in 20 minutes or so. On a larger guide tower, maybe 500 feet, 150 meters, may take 45 minutes or so, but it's a very fast, efficient way of capturing. It also cuts down on the amount of data, which means faster processing times. So once we've captured the data, Pointivo processes it to create the digital twin, and that's what we're looking at here in 3D space. But I also wanted to point out one other thing, and that is the patented scale marker system that we've developed. So Kyle talked earlier about the benefits of RTK, and absolutely RTK is a great solution to ensure that you're getting accurate models. There are other solutions out there as well, but we've developed what we think is a very easy to deploy, inexpensive, portable way of ensuring that the digital twins that we are creating are dimensionally accurate. And so you'll see that it's comprised of two targets. They're at a known distance apart. And so when we create the reconstruction for this tower, we know what that distance is supposed to be. And then we've got a second, and we can use that to scale the model. We use the second set in order to validate that measurement. And from that, we're able to calculate an accuracy score. And so the benefit of this, again, is that it's low cost, it's easy to deploy, and really works quite well for us to get relative accuracy. With that accuracy, we then know that everything in the digital twin is scaled appropriately. And because of that, the measurements that we're taking when our AI detects panel antennas, for example, are highly accurate. We're using those measurements in determining model numbers and so forth, and so we're able to get really enterprise engineering grade accuracy using, you know, relatively, I would call them kind of prosumer drones, the low end of the enterprise drones. The Mavic 3E is great. Historically, we've been working with the Phantom 4 Pros. We can use other hardware as well. We're relatively drone agnostic. Certainly, even better sensors are better yet. But generally, we can work with what the customer has. Close that up here, and I wanted to dive in a little bit on, I touched on engineering grade accuracy and what we're doing there. I'm going to hop into our mount mapping workspace, and for those of you who may not be familiar, mount mapping is conducted generally before any modifications are made to a mount system. So in the US at least, generally each carrier is on their own mount, and each mount is dedicated to just that carrier, and that's where they'll have all of their equipment installed. When they want to add antennas, change out antennas, and so forth, one of the requirements is that they demonstrate that the equipment that they're going to be putting on there is able to be held by the mount system. It's generally kind of bad form if your equipment falls onto the carriers below you. And so in order to do that, the first thing is accounting for what's there. And that means not just the antennas and the radios and so forth that are mounted, but also the structural steel members. I'll turn off a few of the layers here and toggle off the point cloud just to kind of give you an idea of the types of things that we're modeling here. And for the antennas, which are kind of the simpler use case, the first thing that we're doing is forming a 3D bounding volume around the antenna. From that, we're able to get dimensional information. And so if I select that and open up our scene inspector here, oops, we can see it has an area and a volume associated with it. It's got elevation, azimuth, and tilt. It's kind of the pitch, roll, and yaw. And it's got X, Y, and Z dimensions as well. All of the geometry that you've seen modeled here on this mount system and throughout this tower is also, it has metadata associated like this. So we've got metrics for all of that geometry, and that includes things like height above ground level, latitude, longitude, etc. Once we've got the dimensions for an antenna, we are then able to take an extensive catalog that we've built of thousands of different types of equipment for cell towers and filter down that catalog to just those items that are within a small tolerance of the detected dimensions. And then we take the visual characteristics, and I'll toggle on our image viewer here. We take the visual characteristics of the antenna in order to actually make a determination about the specific manufacturer and model. And we're actually looking here, this is one of our patented technologies, this virtual navigation, which allows us to move around, rotate around the tower in 3 dimensions, overlaying all of the geometry that we've generated, but then viewing the high resolution imagery. And so it provides a very natural way to move about the 3D space, see the highest fidelity data that is available, and then also see the modeling that's part of our digital twin overlaid on top of it. So once we've identified a particular antenna, we can actually, I'll find this one here in our list. Here we are. If I expand this out here, I can see the antenna details. The first part of it is a lot of what we already saw in the scene inspector in terms of metrics about the size and location of it. But we also have all of the information from the manufacturer about that antenna, including the model number, dimensions, weight, etc. And if the manufacturer makes it available, we can open the data sheet for that particular model on the manufacturer's website. So that's what we're doing in terms of the antenna detection, and that's antenna detection is part of our mount mapping solution. It's also part of some of the other offerings we have, including inventory reports and others. We are also, as we talked about, modeling all of the steel members. And we're doing it using a very similar approach where it's kind of rough fit using the point cloud. But then we're using, and this is kind of a metaphorical approach, but you can see here as I am scrolling, we're seeing a portion of the point cloud. This is kind of a cross section of this member, and we're moving that cross section along the angle steel here. And you can see where the point cloud is. And obviously there's some noise, there's other objects surrounding, and you can kind of see that as I move along. But we can get a rough idea of what the dimensions of this particular steel member are. In this case, it's a 3" by 3" by 1/4" inch piece of angle. But we take that a step further, and we are using the imagery in order to look at the edge profile and actually make a determination about that thickness. This is all handled in the back end by our AI algorithms. The user themselves has access to this through our tools, and so any changes that need to be made can be, but it gives you the full capabilities as the user. And again, we're seeing the visual navigation here, and can see from all different angles the drone has captured this from the determined member type overlaid on that. So from this information, when we've done a mount mapping, we can produce reports from that. So this is an example of our mount mapping report. It includes drawings like you see here. These drawings are actually exports from the DXFs that we're generating. So we're creating CAD files for these. Images of those CAD files are included in this report. We also have dimensional information, a table of all of the appurtenances that are installed on that mount system, et cetera. And then that repeats in increasing detail for each of the sectors in that mount system. We're applying, and we're running a little short on time here, so I'm going to speed through this here quickly because I want to make sure we get a chance to to answer some questions. But we are applying that same type of technology for other types of reports. So for example, this is a large tower, has over 100 appurtenances installed on it, very heavily loaded, and we're able to create an inventory of everything that's on that tower using the approaches that we talked about previously. In this case, we're focused primarily on that inventory, not so much on the structural elements of the mount system, and are producing a report similar to what we just saw, but really just focused on the inventory itself without the structural drawings. And we can do a similar type of thing, and we're looking here at a different of our visualization techniques, but we can do a similar type of thing with AI detection of deficiencies on a tower. And so, for example, this is a tower in pretty poor condition. On the right here, you can see how we're selecting an image that mimics our position and orientation in the 3D scene. And this is, again, one of those technologies that we think makes our approach to digital twins somewhat unique because we give you such an intuitive way to navigate things. But we've annotated, we've had our AI annotate different deficiencies throughout this tower, and each of these blue dots represents one of those. If I click on one of those, we can also see it overlaid in the imagery. You can see this tower here has holes in many of the members. Throughout the tower, there's a lot of rust. We've got equipment that has come loose here. And if I zoom in, we can see some of the hardware has come loose where this is mounted. And so we roll all of that up into an inspection report, and we've modeled that based on the TIA 222 standard, where we are indicating all of those things that can be reasonably determined from a drone, whether or not we observed any of those conditions. In this case, there are damaged members with some severe issues. So we go through the whole standard in that manner and then provide a visual inventory of the issues that were found. In this case, you can see one of the fences has come down around the tower as well. We also apply the same type of techniques to recognize ground space equipment, and so this is another tower where we've done that, identifying generators, ground pads, and so forth. And to the point earlier about being able to generate CAD files, we can do that with the ground space equipment as well, essentially allowing the user to bring this into a CAD system and do additional planning. So with that, I know we moved pretty quickly through that, but again, I wanted to make sure that we have time to answer any questions. I did want to put this up here and encourage the audience. We do have a survey that we would really appreciate it if you could fill out for us. And then as a thank you, DJI is going to select the 9th and 29th survey respondents in order to provide a Mavic Lego set. So it's a nice token of gratitude for filling that out. Just scan the QR code here. I'll leave that up for just a moment and open it up, turn it back over to Kyle for questions.
Perfect. Thanks a bunch, both Jacob and Colin. That was a super informative. Diving into the platform, you showed some stuff that I have not seen much of any other platforms out there that's able to get the measurements off and get the CAD drawings and all of the actual angles of the antenna. So really good informative information from Pointivo. I am going to launch our last poll question and we'll get into answers. I will get back to this QR code, so don't worry about that. But while we get to the first question, what's the poll should be open. What's the biggest challenge you or your clients have had with physical asset inspection? There's a couple different answers there. And apologize, should add an extra O on the too long. But let's go ahead and dive into some of the questions, starting at the very top. With the POI orbit, can you orbit the line of sight and face away from the tower? It'd be great for confirming microwave link pass. That is a great request. That's one that I believe I have logged one other time in the past 2 months, but currently it is not that possibility is not available in Pilot 2. There may be a third-party solution, maybe DroneLink, maybe it'd be something that UGCS would be able to do, but currently it is not in Pilot 2, but that's a good idea. Felix also asked, is DJI looking for new function for autonomous cell tower inspection? The point of interest function for orbit doesn't have quite the features that he's looking for. That's a great question. Our last firmware release for the Mavic 3 Enterprise, now coming up a couple months ago, came out with the very first version of point of interest orbit. I'm gonna go ahead and close the poll now. And we'll get back to, if you wanna just, we'll shout out the team at Pointivo as well. Then we also have the QR code in case you missed it. But basically all that to say, we're going to continue to release new firmware versions. It's going to bring more of the tools that you saw in Ground Station Pro and level them up to Pilot 2 that aren't there yet. But yes, with the first version, it's a great feature that we're able to see, but we'll keep improving it. What flight app is Pointivo using for flight planning? That's something that you guys built based off of the thousands of cell towers that you guys have captured and analyzed. That's in-house that you guys have with your pilots?
We are partnered with somebody on that. We've highly customized the specific function to meet our flight specs, and certainly if we engage with any of the customers on this call at a deeper level, we can get into more details on that.
We've also had customers that have integrated flight components into like their enterprise flight teams. So, as I mentioned before, we're pretty agnostic when it comes to the capture, although we're pretty opinionated as well about how to make it efficient and scalable. Yeah.
Yeah, and when it comes to cell tower reconstruction, it's one of the hardest things to make a really clean 3D model every single time you go out to the site. And so data capture is very important. But then the data analysis side, as you guys have, as everyone's seen, Pointivo really strives forward on once you've captured. What's the accuracy of the plumbness of fiberglass stick style antennas? Example DB809. I think he was asking that right when we were going through some of the antennas. Can you talk a little bit about accuracy and maybe just about how you guys validate a little bit more?
Yeah, so in terms of dimensional accuracy, I think we quote 3/16 of an inch over a standard like 300-foot cell tower, if I'm not mistaken.
100 meter.
100 meter, yeah, okay. And about a 1/16 of an inch, like 1.5 millimeters, over, say, an 8-foot panel antenna. I don't know that we've done a ton of validation in terms of angular accuracy, but I am confident that we're as good or better than anything else out there.
I think our last our last was somewhere in the neighborhood of 1/2 degree.
Okay.
And that's for tilt and plumb. So
nice, super accurate. Got a couple questions. The last two very similar. Are you able to change the units in Pointivo from imperial to metric?
Yes, absolutely. And inevitably, I always have it in the wrong unit for whichever audience I'm presenting to. I think this is a pretty heavily international audience here. But yes, that's a user setting. Can be changed at any time. Can be changed back and forth as well.
Sure.
It's true of all of the reports that we generate in CAD as well.
Yep.
Good. That's good. The last question, this is more of an open-ended question as we finish up. How do you get in touch with the cell service provider for the land inspection contracts? And he's talking more TELUS and Rogers in Canada. So just one tip of how to kind of get into this from a pilot's perspective, maybe.
I mean, definitely, building a relationship either with the carriers, the tower owners, or engineering companies doing work on behalf of one of those entities. The Pointivo website also for anybody who's interested in providing flight services for us. If you go to the Contact Us link, there's actually a special forum just for drone service providers. And so if you're interested, excuse me, in being somebody that we would contract when we're providing flight services for one of our customers, by all means fill that out. That gets you in our database. And if we have work available in your area, we'll reach out and work with you to do that for us. But definitely the best way to kind of build your telecom flight experience is to build a relationship with an entity that is doing that type of work.
Good point. Well, we are at the 1 o'clock Central Time hour, at least US. So I want to thank both Colin and Jacob for being able to join and show the Pointivo platform. As you can see, if you have any questions for the Pointivo team specifically, feel free to reach out to the email address there. Colin, if you want to back up one more slide, just in case anyone missed it for the QR code, we'd really love to see if you could fill out that survey. I've got my Lego Mavic drone sitting next to me. It's like 400, 500 pieces. So it's a fun project. I highly encourage the survey to get submitted. So
for the record, Colin and I did not get a Mavic Lego set. So we're jealous of whoever wins.
Submit the survey, guys. Just submit the survey. Maybe you'll be the 9th or the 29th.
I think panelists.
I'm
can
assuming
win.
that we're getting the Mavic 3E Lego set, Jacob. That's
Yeah.
that's my assumption.
Maybe
Yeah.
we can make that happen.
Yeah.
Thanks a bunch, guys. This has been recorded, and so we're going to be following up with that and any other questions that we missed. So
Thank
hope
you.
you guys have a
Thank
good
you.
rest of the week.
Take care.
Bye.